This conference will now be recorded.
Hello everyone. So today in this video we will discuss previous year's question from the exam NEET, and that is from the unit equilibrium. Here we have the first question: in which of the following equilibria Kp and Kc, these two values are not same? So here we have total 4 options given, and in these 4 options there will be total 4 reactions. Okay, so let's see in which case Kp and Kc are not equal. Now to answer this question, basically we have to know the relationship between Kp and Kc. So here Kp is related to Kc by this relationship. Here R is universal gas constant, T is absolute temperature, and del Ng, that is actually the difference in the number of moles gaseous products minus gaseous reactants. So you have to check how many moles of gaseous products are present in the right hand side, and you have to deduct the number of total number of gaseous moles that is present in the left hand side. So if you find this del Ng value as 1, okay, so Kp and Kc, these two are not equal, means what? This part must be equal to 1, then only this value will be, we can say that Kp is equal to Kc. Now that is only possible if the power of RT is 0, and power of RT 0 means what? Del Ng must be equal to 0. Then only Kp should be equal to Kc. So here we have to check in which case del Ng is equal to 0. Then only, del Ng it is not equal to 0. So when del Ng not equal to 0, then only we can say that Kp is not equal to Kc. But if it is 0, then it will be equal to 0. Now look at the first equation. Here we have gaseous PCl5 molecule is decomposed to PCl3, gaseous and chlorine gas. So total number of moles, that is gaseous moles, it is 1 plus 1 minus 1, which is for PCl5. So this value you will see it is equal to 1, and this is not equal to 0. That means this should be our correct answer, right? Similarly, in case of second one, H2 and I2 both are gaseous, and we are getting 2Hi, that is also gaseous. So del Ng value, if we calculate, it will be 2, which is for Hi, minus 1, which is for hydrogen, minus 1, which is for iodine, and this is equal to 0. But when del Ng is 0, then Kp-Kc will be equal. But we have to find in which case it is not equal. So this is not our correct answer. Then we are having the third equation where carbon monoxide is reacting with H2O, and we are getting carbon dioxide and hydrogen gas. So all these 4 molecules are gaseous. So just calculate del Ng, it is 1 plus 1, which is for the product side, 1 mole of CO2, 1 mole of hydrogen, minus 1 mole of CO, and also minus 1 mole of water. So this is equal to 0. That means this is also not our correct answer. What about the last one? Here del Ng value is 1, that is for bromine, 1 mole of bromine plus 1 mole of chlorine, minus 2 moles of BrCl. This is interhalogen, bromine and chloride, bromine chloride, this molecule is actually. So it will be minus 2. So in this case also we are getting del Ng value is equal to 0. So in all the cases, these are basically del Ng values. So you have to calculate the del Ng for these 4 reactions, and you have to check in which case it is not equal to 0, because when it is not equal to 0, then only you can say that Kp is not equal to Kc. So del Ng not equal to 0 means you will have some power for RT, and there will be some contribution in the right hand side. So Kp cannot be equal to Kc. Okay, so correct answer here is the first option, right? Next, we will go to the next question. For the reaction 2A, which is in equilibrium with B and C, Kc value is given 4 into 10 to the power minus 3. At a given time, the composition of reaction mixture is like this, where the concentration of the product as well as the reactant all are same, 2 into 10 to the minus 3 molar. Under this condition, which of the following is correct? That we have to find. Now, what we actually have to find, if we read the options, it is saying that reaction is at equilibrium. Then it is saying that reaction has a tendency to go in forward direction. Then in the third option, it is saying tendency to go in backward direction. And the fourth option is saying has gone to completion in forward direction. That means equilibrium is already reached. So basically we have to find the relationship between QC and KC. So when QC is greater than KC, then only equilibrium will be moving forward, which is present in case of, when QC is greater than KC, then it will be moving backward. Similarly, when QC is lesser than KC, at a certain situation, you can find QC, which will actually calculate from these concentrations values given. So when QC is lesser than the equilibrium constant KC, then it will move forward. That means more product should be produced. And if QC is equal to KC, then it is already, it has reached the equilibrium, right? So how to, that is QC we have to find. So for the calculation of QC, what we will do, we will write the expression just like you do for KC. Only difference is that in this expression, the concentration of BCA that you will put, that is at a given time. So it may be any time the reaction is already started, but equilibrium is not reached. Then at any time, the concentration value that is given here, which is 2 into 10 to the minus 3. So there will be square. Now as all are basically equal, so B and C, it is as if you can write it like this, right? Now A and B, their concentration is also equal. So you, without doing any calculation, you can understand this should be equal to 1, right? And now look at the value of Kc. It is 10 to the minus 3. So Qc is basically less than Kc. So it means what? This ratio, as it is lesser than Kc value, that means in the medium, the amount of B and C is more, right? So amount of B and C more means there will be a tendency for the system to move towards, to produce more A, so that the value of QC can be equal to Kc. So if we want to decrease the amount of value of Kc from 1 to this value 4 into 10 to the power minus 3, what we have to do? Concentration of the denominator, that is A, that should be increased. Okay. So the reaction quotient, sorry, I have written it is greater than, because Kc value is 4 into 10 to the power minus 3. So as Kc is greater than equilibrium constant, so what it indicates, concentration of the product and C is too high relative to the concentration of the reactant. So when you increase the amount of A, then only this ratio will be reaching gradually to 4 into 10 to the minus 3. And how that is possible? It is possible only if there is formation of more of A, that is B and C should combine together and it should form more of A, which means the reaction will be having a tendency to go in backward direction. Okay. Here the last option is actually by mistake I have said that it has reached equilibrium. It is not reached, it doesn't mean that. It actually means has gone to completion in forward direction, means all of A is, that is whatever is the amount of A in the medium, that is completely consumed and complete formation of B and C is there. That means 100% reaction is complete. That is the meaning of this last option. It doesn't mean that it is at equilibrium. That is given in the first option. Okay. So first option already equilibrium reached. Option 2 and 3, these two are opposite to each other. And the last option is saying that it has already 100% reaction is done. All A consumed to B and C. But these three are not correct. Only the third one is correct. So that B and C can react together and it can produce more of A. Consider the following reaction. In a sealed vessel at equilibrium with concentration given for nitrogen, for oxygen it is given, and for NO it is given. Now what is the reaction? The reaction is this. Nitric oxide is decomposed to nitrogen gas and oxygen gas. It is already balanced equation. If 0.1 mole per liter, which is basically molarity of NO, is taken in a closed vessel, what will be the degree of dissociation, which is denoted by alpha for NO at equilibrium? So it is asking the value of alpha, which is always something lesser than 1. And from these three values, you can easily calculate the K equilibrium. Once you know the K equilibrium, alpha can be known because the initial concentration of the starting material is given, right? So our first thing that we have to do is to calculate the value of Kc. So find the value of Kc, which is concentration of N2, concentration of O2 divided by concentration of NO to the power 2. 3 into 10 to the power minus 3, 4.2 10 to the power minus 3 divided by 2.8 10 to the power minus 3, and there will be 2. Now look at the power, all the powers will be cancelled, numerator and denominator, and ultimately we will be left with the value 1.607. So this is the value of Kc. Now this value of Kc we will use in the second step, where we will actually find out the value of alpha. Now you have to write this equation. So it is 0.1 initially, these two are not present, no concentration. Then 0.1 and minus 1 into R. It will be something like 0. This. So here I will write it 0.05 alpha to the power 2 divided by 0.1 1 minus alpha, there will be a square. Okay, now Kc value you already know, which is 1.607, and this side it will be 0.05 square alpha square 1 minus alpha square, and this side it is 0.1 square. So if you do the calculation, you will see ultimately you will get the value of alpha square divided by 1 minus alpha whole square, that will be equal to 6.428. And from this, if we take root both side, it will be 2.535. And from this we can calculate the value of alpha. So I am doing the calculation this side. Five, 3, 5. 3.535 alpha. So ultimately the value of alpha is 2.535 divided by 3.535, which is 0. 717, and that is matching with the option 4, that is the last option. For a weak acid HA, the percentage of dissociation is nearly 1% at equilibrium. As it is weak acid, so obviously it will not be fully dissociated. There will be very small percentage of this acid that will be in dissociated condition. Concentration of the acid given 0.1 molarity, mole per liter, then the correct option for its Ka value at the same temperature that we have to find. So here we will write the expression of dissociation for the acid HA first. So it will dissociate to H plus and A minus. So initially the concentration is 0.1. These two are not present. Finally it is 0.1, and as 1% is the alpha. That means here degree of dissociation is 1 divided by 100, which is 0.01. Now 0.01 of 0.1, that is 0.1 multiplied by alpha, that value is, okay, that means it will be ultimately 0.001, and this we should subtract from HA. Okay, so I will write here 0.001, and this side there will be formation of same amount. So this is the concentration, and this value is 0.099. So once we have done up to this point, next thing that you have to do, the dissociation constant of the acid you have to find. So H plus is 0.001, A is also same, so I can write it as square. Okay, so it is 10 to the power minus 6 on the above side, and 0.009. So if you take the inverse of it, you will get something like this. Okay, so it is matching with this option. So option 3 is the correct option. The equilibrium concentration of the species in the reaction A plus B reacting, and it is producing C plus D. Equilibrium concentrations are given 2, 3, 10 and 6. So 2, 3, 10 and 6 for A, B, C, D respectively. Temperature is 300 Kelvin. You have to find del G naught value for the reaction, and remember, look at the unit. RE is given in terms of calorie per mole Kelvin. It is because final answer you have to find for del G, that is also in calorie. Normally we do it in terms of joule, but here it is in terms of calorie. Okay, that you have to be careful about the unit, because if you by mistake put the value of R as 8.314, but if you put it the liter atmosphere unit, which is 0.082, the the calculation will be wrong. Okay, so that is the reason. Just be careful about the units. So here we will find out K equilibrium value first, because once you know the K equilibrium value, then only you can find the del G naught value, because del G naught is related to K equilibrium as minus RT ln K equilibrium. So that is why we are calculating K equilibrium. So concentration of C, all are having coefficient 1, so directly we can put it. So it is 10. Okay. Now del G naught minus 2, this is 300, that is T. Already it is given in Kelvin, you don't have to convert it. Now if I write it in terms of log, by putting 2.303, our calculation will be easier, because log 10 we know it is 1. So it is minus 600 multiplied by 2.303. Final value you will get in terms of calorie. 600. So it is matching with the second option, right? So this should be the correct option. 3O2 is converted to 2O3. So it is a balanced equation. Here oxygen is converted to ozone. For the above reaction at 298 Kelvin, Kc value is found to be 3 into 10 to the power minus 59. If the concentration of oxygen at equilibrium is 0.04, which is the concentration of oxygen, you have to find the concentration of ozone in molarity. So very simple. You just have to write the expression for Kc. Once you can write that, you can calculate the value, right? So Kc, we will write the expression, and it will be ozone concentration to the power 2 divided by O2 concentration to the power 3. So O3 we do not know. So suppose it is x squared, but O2 we know, which is 0.04 to the power 3. Kc value is also given. Now 4, how we can write it? As if it is 10 to the power 3 and 10 to the power minus 2 to the power 3. So ultimately it is this, to this point the calculation is not something difficult. So it is 64. That means x squared is equal to 3 into 64 and the power will be 59 plus 6. That means it should be 10 to the power minus 65. Now this part is 192 into 10 to the power minus 65. Now you can make the calculation easy if you look at the options carefully. You have to find the value of x. So you have to take the root for this total quantity, right? Now when you will take root, if the power is even, it is better. Now look at the options. It is given minus 63. It cannot be our answer at all, because after taking root, it will be reduced to something near about 30, minus 30, right? This is also not correct. Now, if you are stuck between these two, look at this, it is positive. So it is not possible. This is also, even if you ignore the numerical, it is also positive. How it can be correct answer? And this is 32. That means if you somehow write it like this, this part, when you will take root, it will be 10 to the power minus 32. That means this is close to your answer. Even if you are not calculating the root of 19.2, then also we can understand that this should be the correct answer, right? Okay. So just be careful while doing the calculation. You can save your time if you just be a little careful. The pH of the solution containing 50 ml each of 0.1 molar sodium acetate and 0.01 molar acetic acid. This mixture 50 ml pH is you have to calculate. pKa of acid is given. So here we have a mixture of sodium acetate, which is 0.1 molar. Be very careful when you are writing the concentration, because it is 0.1, it is 0.01. It is present 50 ml, and HOAC, that is acetic acid, that is also 50 ml, but it is 0.01 molarity. So this is the mixture you have. Now look at this mixture. This is basically buffer mixture, isn't it? Weak acid and its corresponding salt, or you can say conjugate base. The conjugate base is this ion. So this is a buffer. So you can easily use the Henderson-Hasselbalch equation, because if you use that equation, easily you can find the pH value. So pH is pKa. So this Henderson-Hasselbalch equation that we are writing, that is for the weak acid and its salt, this type of system. So for this type of system, because there are another formula for Henderson-Hasselbalch where you have basic buffer, but we are doing it for acidic buffer. Log concentration of the salt or the conjugate base divided by concentration of acid. Now you can say that it is 50 ml, and when we are mixing it, it is becoming 100 ml. So there will be a dilution, concentration will change. That is true. But even if concentration is changed, it will have same effect for both, and you are taking its ratio. So ultimately it will not matter. So directly you can put the concentration, which is without, that is ignoring the dilution. So for salt it is 10 to the power minus 1, and for this one it is 10 to the power minus 2. So ultimately it will be log 10. That means 1, so it will be 5.5. and that is present in the last option. Okay. Kp value for the following reaction is 3 at 1000 Kelvin. Carbon dioxide, it is reacting with carbon and we are getting 2 moles of carbon monoxide. What will be the value of Kc for the reaction at the same temperature? So Kp is given, but we have to find the value of Kc. So the relationship, if we write Kp is equal to Kc multiplied by RT to the power del Ng. This equation we have already used before. So what is the del Ng value? 2 moles of CO minus 1 mole of CO2, because this is not gaseous, it is solid. So it is 1. That means del Ng is 1. So Kc into RT. Bring Kc one side because you have to calculate Kc. Kp you already know. Now which unit of R that is given, but still you should check it here. Okay, actually it doesn't matter because no volume pressure terms are there, so whether it is liter or joule, it is not important here. Okay, 0.82. Now 0.036, it is not directly given, so you can write it like this. Then it will be equal to 3.6 10 power minus 2. pKb value for dimethylamine and pKa of acetic acid given as 3.27. So 3.27 pKb for dimethylamine, 4.77 for acetic acid. The correct option for pH of dimethyl ammonium acetate solution. So this is basically the salt that will be produced by the reaction between these two. So what is the reaction happening here? You have to write the formula for dimethylamine. It is just like ammonia. But if you replace 2 hydrogen in ammonia with 2 methyl groups, you get dimethylamine. Acetic acid, and there is formation of the salt. That is, this hydrogen will be captured by nitrogen, and ultimately it will be Me2NH plus. So there will be a cation and there will be a counter anion. And this is, we can call it dimethyl ammonium acetate. Okay, so this part is dimethyl ammonium, this part is ammonium acetate. But the important point is pKb value for this one is given 3.27. pKa, because now when we are talking about pKb, pKa, it means what? This is weak base, this is weak acid. So you are basically doing a reaction where weak base is reacting with weak acid and we are getting a salt. So, and this salt, as it is a solution, you have to consider its hydrolysis. So there is a particular formula for hydrolysis of a salt which is produced from weak base and weak acid, and that formula is 7 plus half pKa minus pKb. This is very straightforward. If you know the formula, doing this this question is not something very difficult. Just directly put it. So it is 1.5 by 2 means 0.75. So it will be 7%. It is present in option 2, right? So you have to write the formula for dimethylamine and also you have to write the formula for salt so that you can understand what is the reaction actually happening. This is the reaction between weak base and weak acid, and the salt that is produced, we have to calculate that is, we according to its hydrolysis formula we can calculate the pH value, right? And look at the pH value. As it is a salt of weak acid and weak base, the pH, it is close to the neutral value, which is around 7. So this is also indication that it is actually correct. Because if it is a salt of which is made from weak base and strong acid, the chances is that pH will be towards acidic side. And if it is the opposite, that is the salt is made of strong base and weak acid, the pH will be towards higher side, basic side. But as it is made from weak base, weak acid, so that is it is near about 7. Find out the solubility of nickel hydroxide in 0.1 molar NaOH. Nickel hydroxide solubility, that means it is not very soluble, it is sparingly soluble. And when you have taken in NaOH, which is having some common ion, right? Now ionic product of this nickel hydroxide is given. But when you are having the mixture of these two, because of this presence of common ion, there will be the solubility will decrease according to the equilibrium. So NiOH whole 2, it is basically dissociating as 2 hydroxide ion, right? That means you already have some HO minus ions present in the medium. So the system will try to move towards backward side to maintain the concentration of HO minus same. So its solubility will decrease. But whatever it is, we will here calculate the solubility, and we are not basically comparing the solubility before and after. We simply have to find the solubility. So if it is S, then this side it will be S plus 0.1, basically 2S, because per mole of Ni2 plus there is formation of 2 moles of hydroxide ion. So that is why I have written 2S, but it should be accompanied by 0.1, which is basically for NaOH. Now the Ksp, that should be equal to, that is the concentration of Ni2 plus so it should be S multiplied by 2S plus 0.1 square. Now remember one thing, here solubility for sparingly soluble salt, it is very low. So this 2S is actually having very low value compared to 0.1, and that is why this 2S plus 0.1, it is almost equal to 0.1. And this type of approximations, it is very common when we calculate the solubility, right? So that is why you can write it. It will be simplified to something like this. So it is S into 10 to the power minus 2. And S value is 2 into 10 to the power minus 15. Yes. Okay. So this is matching with second option, right? So first we have to write the dissociation equation for NiOH whole 2. Then you just consider the concentration of HO minus, that is a contribution of NiOH, that also you have to consider. And this approximation is important. If you do not apply it, calculation will be very difficult. There will be a square term and unnecessarily it will be complex. So 2S plus 0.1, it is almost equal to 0.1, because this part is very small compared to 0.1. So ultimately the equation will be simplified and you can calculate the S value. Hydrolysis of sucrose is given by the following reaction. Sucrose plus H2O. After hydrolysis, the products we are getting glucose and fructose. If the equilibrium constant Kc is 2 into 10 to the power 13 at 300 Kelvin, the value of ΔRG, that is enthalpy change of the reaction, at the same temperature. Now this is a really very easy question and very straightforward. If you know the relationship between ΔRG and Kc, it is RT ln K or Kc, whatever it is, right? So your R value is 8.314, because here all the options are written as 8.314, so you don't have to worry about it. Then 300 Kelvin multiplied by ln 2 into 10 to the power 13. So even you don't have to do the calculation. They have directly given the expression, but there should be a minus sign. Now in these two equations there is no minus sign, but the other two there is a minus sign. But look at this value. It is the Kc value is not like this. It is 2 into that is why the second option is the correct option. So it is simply you just have to put all the values, but you have to know this relationship. And this negative sign is also important because third and fourth option there is no negatives. Okay. pH of a saturated solution of calcium hydroxide is 9, and the solubility product of calcium hydroxide that you have to find. So pH of saturated solution 9. So when you know it is 9, you can calculate pOH. Now why I am calculating pOH? Because pH and pOH, these two together, the value is 14. If you know the relationship from this, you can calculate pOH, which is 5. 14 minus 9, it is 5. But why we are calculating pOH? Because if you know the pOH value, you can calculate the concentration of HO minus, which is basically 10 to the power minus pOH. That means it is 10 to the power minus 5. Now, why we need HO minus concentration? It is required because you have to calculate the Ksp of calcium hydroxide. And for calcium hydroxide, just like the problem we have solved, nickel hydroxide, here also same thing. When you will write the expression, you will see there is HO minus ion. Now, pH of saturated solution is 9 means there is already some concentration present. The contribution of HO minus, it is not just from CaOH whole 2, but it is also from some other source. That is why the pH is mentioned specific. And if the pH is mentioned like this, and even if other source is not present, but you know that pH of the medium is 9, that means pOH of the medium is 5, it is another way of saying what is the concentration of HO minus. Because to calculate the Ksp for calcium hydroxide, you need to know the concentration of HO minus. And if you know this, if it is 10 to the power minus 5, this one will be 10 to the power minus 5 divided by 2, because the mole ratio is half for the cation. So that is the reason why we are calculating pOH, because once you know pOH, then only you can know hydroxide ion concentration. Now if you put it 10 to the power minus 5 square, so it is 10 to the power minus 15, and half means 0.5. So it is matching with first option, right? Which will make basic buffer. So here total 4 combinations are given. So one by one, if we solve it, we will be able to understand. It is a mixture of NaOH and CH3COOH. Now we know when we have volume in ml and molarity is given, if you directly multiply these two, you get the value in terms of millimole. And this is the way the calculation becomes very easier. So just do it. 50 into 0.1 is 5 millimole. So initially you have 5 millimole of sodium hydroxide, and 25.1 means you have 2.5 millimole of acetic acid. What salt you will get? You will get sodium acetate and water. So initially these two are not present, but finally this will be remain, because this is not the limiting reagent. It will be completely consumed, and this is also 2.5 millimole, right? Now in the medium, finally what is left? There is NaOH left and some excess NaOH left, the reactant. Solution will be basic because of this presence of NaOH, but this is not a buffer, because buffer means the mixture of weak acid and salt or weak base and salt. It is true you have some weak base, you have some salt, but it is not, that is a base present is strong. So this cannot be basic buffer. And we have to find basic buffer. So this is not a correct answer, correct option. Okay. Now the second one, this is also acetic acid and NaOH, but this time 100 ml 0.1 molar acetic acid. That means it is 10 millimole. So I am directly without same calculation. That is same equation. I am not writing it again. Initial amount 10 millimole for both. So for the salt, initially it is not present, but finally after reaction it will be 10 millimole. So in the medium there will be only 10 millimole of a salt which is produced by the combination of strong base and weak acid. And there will be some hydrolysis of salt. But you cannot say that this is a buffer. This is not buffer according to its buffer definition. So this is also not our correct option. What about the third one? Now we have HCl, NH4OH, and there is formation of salt NH4Cl and H2O. Initially 100 0.1, that means it is 2 millimole, and this is 200.1, that means 20 millimole. This is not present in the right hand side. Here this is the limiting reagent HCl, some NH4OH is extra, and NH4Cl produced will also be 10. Now these two mixture of NH4Cl and NH4OH, this is actually mixture of weak base and its salt. This is actually our basic buffer, isn't it? So that is why this should be the correct answer. But why the last one is not correct answer, we'll just check it. Here we have again HCl and okay, this is different. This is strong base, strong acid. So 10 millimole HCl, 10 millimole NaOH, these two are not present. So it is 1:1 reaction. So in the medium, you just have 10 millimole after the reaction, 10 millimole of sodium chloride. And if you consider hydrolysis, basically for the salt made from strong base, strong acid, we do not use the term hydrolysis, but the solution will be actually neutral. Fine. So it will not be the correct answer. The third one is the correct answer. That is this calculation. Which one of the following conditions will favor maximum formation of the product in this reaction? So which is the what is the reaction? A2 gaseous, B2 gaseous, it is producing X2. This information is important because the sign indicates that this is an exothermic reaction, and for exothermic reaction, when the temperature we increase, the product formation is hampered because in the reaction there is already some excess heat generated. That is why there is a negative sign. Heat is released. Now already heat is released and again you are adding more heat. It will not be favorable for the product formation. So low temperature will be favored. Any of these two options will be correct, not these two. But what about the pressure? How to decide that? See, here you have 1 mole of A2 gas, 1 mole of B2 gas, and in the right hand side you have 1 mole of only X2. That means the total volume amount, it is higher in the reactant side. Now when you are increasing the pressure, suppose if you are thinking that high pressure will be favored, is it so? Just check. So when the pressure is high, the system will try to move towards that side where volume is low. And if you decrease the pressure, that means high volume is okay, because pressure and volume, these two are opposite related to each other. So that is the reason here high pressure will be favored, because when you are applying high pressure, the system will try to move towards that side where volume is already less. And which side is volume less? It is the product side. And the question is asking maximum formation of product. So obviously we will try to move toward X2, and that is possible if your pressure is high. So low temperature, high pressure, these are the favorable conditions for this reaction for better X2 formation. equilibrium equations given and the corresponding K1 value, K2 value, K3 value. You have to find equilibrium constant for the fourth reaction. Suppose this is a fourth reaction. Now in the fourth reaction you have ammonia, oxygen, NO and H2O. And look at these three reactions. Here you have N2 and NO also. But N2 and not NO. N2 and ammonia, these two are not present in the final equation. There is no N2, there is no ammonia. So you have to arrange these three equations in such a way so that you can get the equilibrium, you can get the equation number 4. So somehow you have to arrange this equation in such a way that you can cancel N2 and ammonia, because these two compounds should not be present in the final equation. And you will see it is possible if you reverse equation 1. So when you inverse equation 1, what you get? You get 2 ammonia is converted to N2 and 3H2O. Next, if you add equation 2 directly, now why I am doing so, you will get to understand it. 2NO. So NO, 2NO we required in the right hand side. So if we write it in this way, it is okay. And the last one, you have to, you need H2O. And here H2O 3. That means you have to multiply this equation with 3 so that you can get 3H2O in the right hand side. So equation 2 directly we have written, and the equation 3 is multiplied by 3. So when you do so, it is 3H2 plus 3 by 2O2, and in the right hand side it is 3H2O. Now if you add all these equations, what you will get? You will see here N2 cancelled, then ammonia, 2 ammonia, sorry, ammonia will be there. I have not written it. N2 should not be there. So 2 ammonia, then 3 by 2 O and 1 O, that means it will be total 5 oxygen. Then you have to write 2 NO, sorry, no hydrogen is present basically. So no N2, no hydrogen. So hydrogen cancel, 2 NO, 3 H2. Now you have obtained the final equation, that is equation 4. But as you have done these processes, so ultimately it should be equation 1 K1 that you have to reverse. So that means it is 1 by K1 multiplied by K2, because we have not changed equation, second equation. And the third equation, as we have multiplied, so there will be a power. So K2, K3 to the power 3 divided by K1. That should be our answer. So the first option is the correct option. We are ending the session here. Thank you for listening.